Now, the fifth example is going to be about a mechanism that using a crank or the link AB that rotate at the angular velocity of 8 radian per second. We need to find what will be the angular velocity of the gear F. So we said here that we need to find actually the a procedure to do the solution. So the procedure can be summarized. I'm going to mention it orally. I explained that in the class. We're going to start first by using the omega of the AB. It's rotating around a fixed point A. So we know the length of the link. I can find the velocity at the B, which is going to be at this instant horizontal. Okay, simply is going to be the 8 radian per second multiplied by 75. Okay, so it's going to have negative direction. Now, let's go to the point C. I would like to know what the direction of the velocity at the point C. Again, the point C is going to be rotating around the link DC. So it should be perpendicular to the link DC. As this link is going to rotate to the anti-clockwise direction, it will going to pull this link, and this one, as expected, is going to be rotate in that direction. So the velocity at C is going to also have a horizontal component only, which is going to go to a negative direction. So the next step is find the relative velocity equation between the VB and the VC to find the VC. Step number 3, I'm going to use the VC. I'm going to multiply it by, divide it by the length of 150. I'm going to find the omega of the gear A. Now, the omega of that green part is going to be the same at any point, but the velocities are going to be different. So I'm going to use that omega. I know the distance from here to here. Okay, so which is 100 millimeters, and this will give me the velocity at that point, which is going to be in this direction. I'm going to find the VP, which is the contact point between the two gears. If I know the value for the velocity VP, and I know the radius of the gear F, I can find the omega of that gear. Okay, now I just mentioned the procedure as word of mouth, but you can simply see the steps of the solution. So, well, actually, this should be ticked by one, but it's shown all the way. So anyway, I'm going to show all the solution. So since AB is subjected to a rotation about the fixed axis, the velocity of the B is going to be equal to the omega AB multiplied by the RAB, which is 75 millimeters. So we're going to have 8 multiplied by 0.07 meters, and this will give you 0.6 meter per second or 600 millimeter per second. Now we are going to apply the relative velocity equation between the point B and the C. So mainly, as I mentioned, the link is going to be like that. That's the point B with this velocity. And the point C is going to have also the same velocity direction because we proved that already. It's going to be here. Okay. Now that link is going to be changed into two components. This is the I component. This is the J component. Okay, so for the I component, it's going to be equal to the 100 millimeter multiplied by the cosine of the 30, while the J component is going to be equal to 100 millimeter multiplied by the sine of the 30, both positive because it's going to go to the right and it's going to go upward. Okay, so we can write now the relative velocity equation as the VC is negative VCI, the VB is negative 600I, the RC slash B is going to be 100 cosine of 30I plus 100 sine of the 30J. We multiply that by the omega of the BCK, and we're going to get the answer to be negative 100 sine of 30 omega BCI plus 100 cosine of 30 omega BCJ. Now we're going to substitute that in the relative velocity equation, and we are come up with the following equation. So once again, you can see that we are going to have 1, 2, 3 components of the I and 1 component of the J. From this component, simply I can say that the 100 cosine of 30 omega BC is equal to 0, and that means that the omega BC is equal to 0. For the other part, when knowing that this one is equal to 0, that means that part is going to go to 0, and then the VC is equal to 600 millimeter per second. Okay, now I know the VC value, which is going to be 600 millimeter per second. Now the rest of the solution is going to be just finishing the solution for that part. Okay, so I will come to vertical part. Okay, so let me sketch that. This will be the gear. Okay, so the velocity is acting in that direction. The rotation is going to be around this point. This will cause the whole gear to rotate in that direction. So I know what the distance from here to here. Okay, so the V multiplied by that distance of 150 will give me the velocity, the omega, the omega is going to be equal to the velocity divided by that distance, or 600 divided by 150, and this will make it equal to 4 radian per second. Now I can find the velocity at the point of the contact between the two gears by multiplying this omega by the distance of 100 millimeters here. Okay, and 4 times 100, this will make it 400 millimeter per second. Then the 400 to be divided by 25, and this will give me what the omega of the gear. Okay, so that's the VP, 400, divide that by 25, and this will give me that the omega of the gear F is equal to 16 radian per second. Okay, so that's it for this example.